These two are important problems, so practice it, and if any problem or query arises, don't hesitate to comment in the comment section. Now, this problem is reduction potential of the half shell PT H2, pressure is kept 1 atm. So, it is kept identical to that in the standard hydrogen electrode, and this is H plus, concentration is changed from 1 molar to some other concentration, so that the reduction potential has changed from 0 volt to minus 0.3 volt. So, reduction potential of the given half shell is minus 0.3 volt at 25 degree centigrade, and you have to find the pH of the solution in the half shell. So, since there is H plus, they are asking you to find the pH of the solution. It is an easy problem. We have done much more complicated problems than this one. So, you will use the reduction format. So, the reaction is 2H plus 2 electron reversible H2. Since the cell given is the half shell, that is given, it is half shell obviously, not shell. So, pressure is 1 atm, this is in gaseous state, and H plus, it is aqueous, and its concentration is required. So, the reaction that will occur is 2H plus 2 electron reversible H2. Now, the Nernst equation will be E2H plus H2, this is in reduction potential format, So, E0 2H plus H2 equals to E0 2H plus H2 minus 0.0591 by, that is a transfer of 2 electrons. So, it is 2 log, it will be pressure of hydrogen by concentration of H plus squared. So, this is the Nernst equation that we will be able to write for this reaction. Now, it is given that the voltage is the reduction potential, it is, see, this is given, this reduction potential is given. So, we have written it in the form of reduction potential. So, no problem, we can put directly here minus 0.3 volt equals to, now this is the convention, this is the standard hydrogen electrode, and its voltage will be, it will be equal to 0 volt. So, you put here 0 volt and it will be minus 0.0591 by 2 log, we put the value of pressure that is given, it is 1 atm, 1 atm pressure is maintained. So, it will be 1 by H plus whole square, or we get, let us take this to the right hand side and take this unit to the left hand side. So, it will be, or rather multiply it by minus 1, no problem. So, it is 0.0591 by 2 log 1 by H plus squared equals to 0.3, this one. Now, since we are using this 0.0591, it is guaranteed that we have used the temperature 298 Kelvin, that is 25 degree centigrade, and that is given in the problem. So, you have to mention here 25 degree centigrade. Now, take this 0.0591 to the right hand side. So, we will have 1 by 2 log, let us take the denominator to the numerator. So, it will be H plus whole square. Now, there will be minus here. So, if we inverse this numerator and denominator, there will be a negative sign outside. So, it is 0.3 by 0.0591. Now, in competitive exam, do not take the calculator, it will simply waste your time. See, this is 0.0591. So, to a good approximation, we can consider it to be 0.06. Now, it is 0.3 above. So, if it is 0.3 above, it will be, see, that will be 30 by 6. See, we multiply both the numerator and denominator by 100. So, it will be 30 by 6. Now, it will cancel to give 5. In competitive exams, if such problem is there, do not use the calculator to waste your time. So, simply consider this to be 0.06 and you will get the answer. Now, see, you have taken a little bit greater than the actual value. So, what you will get here in original, it will be little bit greater here. So, that option will be given and the other options will not match that value. So, you can predict the correct option to a very good approximation. So, this will simply save your time. Now, we take this 2 to the outside. So, it will be 2 by 2. So, it is 1. So, minus log h plus. See, this power is coming to the coefficient area and this 2 will cancel out. So, we will get minus log h plus, which is the pH. So, pH will be 5. Now, that will be a very small amount greater than 5. Let us check with calculator what it comes. See, it is 0.3 divided by 0.0591. See, it is 5.076 as I have predicted. So, it is 5.076. So, this is the answer. The problem is done, but I am giving emphasis in every problem that try to fill the result you obtained, so that the understanding becomes clear. See, when the pressure is 1 atm and concentration is 1.0 molar, it is the standard hydrogen electrode and the reduction potential is 0 volt. Now, this is unknown, this is same as that of the standard hydrogen electrode, and this reduction potential that is given is minus 0.3 volt at 25 degree centigrade. Now, you see the reduction potential is decreasing, that is tendency to get reduced is decreasing. The reduction potential is decreasing, that is tendency to get reduced is decreasing. Now, tendency to get reduced is decreasing means the forward reaction is less occurring, since forward reaction is the reduction process. Now, the only way to have the forward reaction in less extent is to lower the concentration of this H plus ion. Now, if it is less than 1 molar, what will be the pH? Let us see. If it is 1 molar, then what will be the pH? It is log 1, that is 0. So, pH will be 0. And if it is less than 1 molar, say 10 to the power minus 5, say this is 10 to the power minus 5, just for example I am taking it 5 molar, then what will be the pH? It is minus log concentration of H plus. So, here we have to put 10 to the minus 5. So, minus 5 will come here. So, minus 5 and minus will be plus 5 and log 10 will be 1. So, then it will be 5. So, what we are predicting is correct and that result is obtained. See, this reduction potential has decreased. So, it means that the tendency to get reduced decreases, that is this forward reaction is, that is the reduction reaction is occurring in less extent, and for the forward reaction to occur in less extent, the concentration of H plus ion must be less, and if the concentration of H plus ion decreases, then only pH will increase from 0. So, you see this result is not absurd and it is correct result. So, in this way you have to check, but you have to do it in fast, since saving of time is very much important. So, by this method you can check whether your problem is correct or not. So, what is the answer? Your answer is this pH of the solution, and at the end, if it is in your final exam of higher secondary, please write the answer at the last, that pH of the solution in the half cell is 5.076. So, that will bring completeness in the solution, since in such exams representation is important. Now, this problem. So, we have reduction potential here. So, cathode reaction is Ag plus electron, reversible Ag. Now, anode reaction is Mg2 plus 2 electron, reversible Mg. Now, since there is this is a 2 electron transfer process and this is a single electron, we multiply here by 2 on both sides. Now, actually in anode oxidation is occurring, but we are writing it in reduction form. So, we have to subtract anode from cathode. So, it will give us the cell reaction, and it will look like 2 Ag plus minus Mg2 plus reversible 2 Ag minus Mg, or rearranging the sides, we have this Mg will come to the left hand side. So, it will be Mg plus 2 Ag plus Mg plus 2 Ag plus, this will go to the right hand side. So, it will be 2 Ag plus Mg2 plus. So, this is the cell reaction. Now, we know that magnesium is a very much electropositive element, highly electropositive element, and its electropositivity is greater than silver. So, in the cell reaction we will experience that magnesium will reduce silver plus to silver. So, magnesium will reduce this silver plus to metallic silver, that we will experience in the reaction. Now, the cell reaction is not important here, we just want to know the number of electron transfer, since they are asking you to give the amount of electrical work. Now, in the former lectures, in maybe in the lecture 3 or 4, I have told you that del G0 equals to minus NF E0 cell, and it is equals to minus W electrical work. So, the electrical work is connected to the Gibbs free energy change in the standard state, and it is connected to the standard electromotive force of the cell through this relation. So, it implies W non mechanical work, that is the electrical work, to be equals to NF E0 cell. Now, we have 2 electron transfer here, see 2 electron transfer. So, 2 into 96500 coulomb into what is the E0 cell, that we need to find out. So, this cathode reaction have the E0 value plus 0.8 volt, and this one minus 2.36 volt. Since we have to subtract the anode reaction from the cathode reaction, so to get the value of E0 cell, we have to subtract the electrode potential of the anode from the cathode, since it is given in reduction potential. So, it will be E0 Ag plus Ag, this belongs to anode, this belongs to cathode, minus E0 Mg2 plus Mg. So, this belongs to anode. Since it is in reduction potential, we have to subtract anode voltage from the cathode one. So, it will give us plus 0.8 volt minus 2.36 volt. So, it will be, so we need calculator. .8 plus this minus will be plus 2.36 volt. So, it is 3.16 volt. So, the electromotive force of the cell will be 3.16 volt. So, you put here 3.16 volt. Now, this volt coulomb is joule. So, we multiply this by 2 by 96500. So, it will be 609,880 joule. So, the electrical work that will be obtained from the cell is 609.88 kilojoule. This is the answer. So, this is all. Now, try to solve almost all the problems that you will find in your textbook, and if you have more time, then try to collect numerical problems from various standard textbooks and solve it. The more you solve numerical problems, the more understanding becomes clear in the subject and the more your intuition develops. Stay with me for the upcoming lectures, which are also interesting, and thank you. Have a good day.